Well, hello everybody, and welcome back. This time, together we are doing Chapter 8. This is digital storage, preserving content locally and on the cloud. Let's begin then. So this definition on this slide of a storage medium is physical, even if we're using the cloud, right? Because that's physical for someone else, a third party. So in computers, a storage medium is any technology, including devices and materials, that's used to place, keep, and retrieve our electronic data. It refers to a physical device or component in a computing system that receives and retains information relating to applications and users. Oops, there we go. There we go. Now, here are some examples of storage media. Things like a CD-ROM, a DVD-ROM, a DAT tape, DLT tape, disk drives, SSDs, flash drives, compact flashes, cassette tapes, blah, blah, blah. The list goes on and on, right? Anything that can record or store data for reading later. These examples of storage devices seem obvious. Again, for cloud storage, information on servers are accessed via the internet, via a browser, or on an app. So a storage medium does not have to be electronic, though. Keep in mind that a storage medium can even be pen and paper. Notches on a stick or even DNA or RNA can be used to store data. Just kind of to blow your mind just a little bit. So storage devices are used to store data and instructions permanently. So these storage devices are also called secondary storage devices, sometimes called backing storage devices, sometimes called external storage devices, or even, I've heard it say, auxiliary storage devices. And some examples that we'll go through here in a few minutes include a hard disk, CD, and DVD, etc. In fact, the magnetic tape is the oldest storage device, but, as we'll discuss, still used. Now, reading involves an already recorded file. Writing is laying down the pieces of a file in an order that can be later retrieved, right? So it's very, very interesting. Now, typically a file is scattered about on a drive, and a map of where the pieces are at is created. So reading aspect is going to use the same map to recreate a whole file for us. And the first disk drives began as spinning disks or platters. We're going to discuss platters later on hard drives. And so the distance around has changed as you move in or out of the platter. So that's really all I want to discuss on that one right now, but it's just interesting, and we'll come back to platters in just a little bit. Now, the amount of storage does not directly affect the speed of a processor, yet storage capacity can indirectly affect the overall performance. So that's an important nuance. Recall that bytes are characters, and that bits are the smallest units in a computer that come together in generally 32-bit strings to form a byte. So a terabyte then would be 1 trillion bytes. Now my company logs data in terms that exceed terabytes per day. Huge amount of data. And as a guide, a gigabyte is about 1 billion bytes. So what is 1 billion bytes? Well, it's about 500,000 pages of a book. It is about 600 photos or 250 songs, right? I mean, it's relative how long are the songs and what's the quality of the resolution and stuff. Or about 15 minutes of high-def video is what you're going to get out of a gigabyte of information. Now recall, as we previously discussed, that volatile memory, in contrast to non-volatile memory. Volatile memory is computer memory that requires power to maintain the stored information. It retains its contents while powered on, but when the power is interrupted, the stored data is quickly lost. And most of the general purpose random access memory, we called it RAM, is considered your volatile memory. Now, for example, a volatile screen displays the required number of pixels by periodically and electronically refreshing them to retain their state, right? Especially on an LCD or liquid crystal display type monitor. So a volatile display only shows an image when it has power, either from battery or AC power. Your monitor is plugged in right now, continually refreshing and giving us the quality that we're looking for. Now, this is something that we've discussed in previous lessons and also a few slides ago, that the concept of most RAM, random access memory, is volatile. So I'll just move on from that. Hopefully there are no questions. If there are, write me, but there shouldn't be, I think, at this point. Now, some storage is non-volatile, as we've discussed. So non-volatile memory, as a review, is a type of memory in which data remains stored even if it's powered off. ROM, read-only memory, ROM is non-volatile, whereas RAM, we just discussed, is volatile. So this term often refers to the CMOS memory in the PCs, which holds the BIOS, right, which is the data called basic input-output system. It's the boot up process, right? It's stored even if we're powered off. So when we power on, the computer goes to reach for it, pulls it into memory, and starts up our system. So now we've clarified volatile and non-volatile memory. Now, continuing with storage. The hardware that defines the computer is the CPU and the memory, right? The CPU and the memory work together to run programs, as we've discussed. So the CPU executes programs using this fetch, decode, execute type style. So in memory, it's going to store these program operations and data while the program is being executed. So the storage drive houses the programs and files. The speed of the storage drive plays a big role in determining how fast the system is able to boot up, load applications, and access anything that you've saved. Now, the processor accesses the storage drive and transfers long-term data to the memory for short-term access, right? This is like a moment-to-moment operation. So, for example, when you go to launch a program, your system's processor has to access long-term data from the storage drive and convert it to a usable short-term data that can be accessed via the memory, right? And then finally, I just want to mention that the processor accesses that data again from that memory to run these programs. And at this point now we can edit files and toggle between different applications. And again, the speed and amount of memory installed helps determine how fast applications are able to load and operate. And it also helps determine how effectively your computer can multitask. So access time then is the total time it takes a computer to request data and then for that data request to be met. It pertains access time to devices such as memory and hard drive and CD-ROMs and other mechanisms. Notice I just mentioned volatile and non-volatile memory. So computer access time is commonly measured in nanoseconds, and the lower the time, the better. So the faster, the better, of course. This slide demonstrates that the access time of storage devices is slow compared to the access time of memory, right? So you have the slow at the bottom, that's the storage devices, and faster at the top, that's memory. Memory works in nanoseconds, and storage often works, so storage devices often work in milliseconds, right? So in addition to the transfer rate is the speed of the data, the instructions, and the information transferred to and from a device. So transfer rates are indicated by the circles on the slide. So I'm going to pause there. We'll take a quick break. We'll come back with hard drives in the next segment.